Hello, we are Team Honeypot. The objective of our project is to log malicious activity, is to set up multiple honeypots on Google Cloud in order to log malicious activity uh, and capture malicious files downloaded by attackers into our honeypots. The honeypot we use is called Cowrie, which is developed by Michael Osterhoff. It's available on GitHub and it's open source. It's an SSH and Telnet honeypot. So it has port 22 and 23 open, and it logs activity on these ports, processes that log, and then outputs the process log to a user interface, which in our case is a Slack feed. The honeypots also save malicious files downloaded by attackers and automatically sends those files to VirusTotal to be analyzed. And then after 5 seconds, the honeypots will get the report from VirusTotal, and in the case where VirusTotal was able to identify the file as a virus, it would send a link to that report to Slack. Otherwise, it would tell Slack that the file it was not tagged as malicious. So that was a general system overview. Now I will show you the honeypot actually working. So here is the Google Cloud Platform console, and it shows you all the instances I have running right now. As you can see, we set up Cowrie honeypots in a variety of geographical locations. And all of those honeypots output their logs into a Slack feed, shown here. So most of the stuff that gets outputted to the Slack feed is actually just routine attacks that are fairly harmless and well known. So every now and then you get something interesting. So right now, I will show you what it looks like from the attacker's perspective by telnetting into one of our Cowrie honeypots that's actually in Southeast Asia. So we logged in as root with a dummy password, and let's poke around as the attacker would do. So in the root directory, you see all the files that you would typically see on a Linux machine. So everything looks okay there. So now we're going to go ahead and download our malicious code into the honeypot. So here, before this demo, I've uploaded all the malicious files that we've gathered from our honeypots over a 3-week span into GitHub. What Cowrie does is when it gets a file downloaded by attacker, it saves it saves it as its file hash. This way we get no duplicates. So let's just click on a random one and download it into our honeypot. So as we can see, it's downloading. And in our Slack feed, we see the blue message here says that, oh, someone's trying to download malicious code into your honeypot. And then after 5 seconds, it will return a link to the virus scan, which will go now. We'll go there now. So this is a Mirai Trojan virus. It's sort of a botnet type malware. So VirusTotal has seen this file before, so what it did was it took a file hash of the file that we uploaded and just ran it through its database and outputted the analysis that it already did. And what we can see here is that this is an ELF32-bit executable in ARM and statically linked, and all sorts of other information. And as we can see by the comments here, other people who have run honeypots also got this exact same virus. So that's interesting. Now, let's try something else. So what we've seen with attackers is that instead of downloading their files from some IP address, they will actually compose their files in the command line, like so. So we create a file called malicious.file. And then if we exit the honeypot, just like files that were downloaded using wget or something like that, files composed on the command line are also saved and run through a virus scan. And as you can see here, we got a negative result from VirusTotal. So this file was tagged as not malicious, which it's obviously not. So as a final part of the demo, I will show you a serious flaw in our honeypot, which would be in future work. So now let's, as before, compose a malicious file. So as you can see, this file, when we compose it or download it, whatever you want to do, is not executable. So a common sense attacker will go ahead and change this to an executable file. So everything seems to be all right, but as you can see, it's not executable. Now the reason for this is chmod is programmed as a valid command in the backend of Cowrie, of the honeypot, but it's not programmed to do anything. So it's a valid command, but it doesn't do anything. And when we would try to execute it the normal way, it would say command not found, because there is no hard-coded command in the backend of Cowrie that's called /malicious.file. So this is how an attacker might be able to see that this is not an actual Linux machine and that it's actually a honeypot. But we've actually missed the opportunity to download a lot of malicious code because of this flaw in the honeypot design. So thank you for listening. That's it.